Hello everyone. So in this part 2 video, we're going to look at these problems for module 9, and make sure to try on your own if you can. Okay, and I know this is a part of the lesson, right? So if you don't know how to do it, just look at, for example, part A and try part B on your own, then look at what I do. Okay, so it is important that you stay engaged and active as you watch this video. Okay, and I'm also going to explain some concepts in addition to the part 1 video. Okay, because this is one of those sections that there's so much I can demonstrate in examples in a slideshow that I make. That's why I'm making this part 2 instead of just another problem video. Okay. So first one, use the property of logarithm to expand the expression as a sum, difference, or constant multiple of logarithms. Okay, and express powers as factors. So that means we want to express this using sum or difference or constant multiples. Okay. So what we can do is, since it's log a, we can first separate into, what we have to recognize is two things multiplying, x squared times this cube root expression. So we have two terms here. So I'm going to separate into log a of x second power plus log a of entire cube root expression, 5 plus x squared. Okay. Now he said express powers as factors. That means I'm going to bring this square right here. Oops. Sorry, this square right here into the front right here. Okay, so let's do that on the next line. So I have 2 times log a x. And actually that's all I can do for this side for now. Okay. So what can we do in the right side? This one, before we bring down the power in front as a factor, we're going to rewrite as an exponent first inside. So I'm going to write log a cube root is same thing as 1/3 power, like this. So the next line, I'm going to copy this part. Now here I can bring this 1/3 to the front as a factor, multiply. So plus 1/3 log a, and inside 5 plus x squared. Now here, this is knowing when to stop is part of the problem. Okay, being able to simplify the problem. Here, this is the final answer. Now you might be wondering, can we bring this 2 right here? This 2 to the front? We can't, because this 2 is only applied to x. In order to bring as a factor, it has to be the exponent must apply to the entire expression inside of the log, like 1/3 here. Okay, so keep that in mind. So part B. Okay, so part B, let me change color. Okay, so first thing we actually, so we have a ln of this division to the 5th power, right? So since it's division, yeah, we do have to separate into subtraction. But before we do that, we need to actually bring this 5 first. So we have 5 times ln of x minus 5th to the 3rd power over the square root. I'm just going to write it as x to the half power, like this. Now we have 5, and I'm going to put big parenthesis here. Now I'd like you to pause the video and fill this blank right here. And of course, I'll write the answer in a second. Separate this into subtraction. Okay, so pause the video and try now. So when we separate, we have ln of x minus 5 to the 3rd power minus ln of x to the half power. Notice that we had only one log, one ln. Now we have two ln, right? Two natural log. So we separate into subtraction of the numerator part minus denominator part. Now we have to rewrite it as exponent, as a factor right here, and half go right here. So we have 5 parenthesis 3 ln x minus 5 minus half ln x. Now we can distribute this 5 right here to this expression and this expression. So our final simplification is 15 ln x minus 5 minus 5 over 2 ln of x. So this is our final simplification, or expanding. Okay, so this one is same as one I went over in part 1 video. So why don't you pause the video and try on your own. Okay, now we're writing expression single logarithm. So we have 3 log, we're going to write in 1 log. Okay, so pause the video, try on your own, and come back. So here first we have to bring this exponent, or just bring this factor as exponent. So I have ln of u to the 3rd power plus ln of v to the 6th power minus ln of w to 3rd power. So we can do one at a time. This one means ln of u 3rd times u to the, sorry, I keep confusing u and v to the 6th power minus ln of w3. Then we have 2 logs now. We can do subtraction, means we can combine into 1 natural log and u 3rd v to the 6th over w 3rd. Okay. So again, note that now we have 1 natural log. We had 3 in the beginning, right? We had 3 logs in the beginning. Now we have 1 log. Okay. So make sure you pay attention to that as you. Okay. Okay. Then now let's look at this one. Okay. Same idea. So pause the video, try on your own. Okay. Okay. So let's see. First, we need to bring the exponent. We'll bring it to exponent, the number factor. There's no exponent second term. And first one, here we have x minus 1 to the 2nd power. Make sure you put parentheses around it. Otherwise, it's going to look like you bring 2nd power to only 1. Okay. So then let's combine this. We can do with from the left to right side. Let's do this one first. Since it is subtracting, we have same base log. We do x plus 3 1/3 divided by x plus log a x minus 1 square. Okay. Now we're going to print 1 log base a, and we multiply. So we do this one multiply this one. Okay. So let's write it. We have x plus 3 1/3 times x minus 1 square over x. So this is the final answer. Sorry, this is x minus 1 here. This is the final answer. We just put in one log expression. So again, these skills are very important when we solve for logic. Okay. So now we're going to different type of problem when we solve. Right? Solve following equations. Remember, solving and simplifying is different. Solving means we're finding input quantities will make this equation true, the statement true. Okay. So let's look at this problem, right? So here, first we have to differentiate between log equations and exponential equation. Here, this is exponential because there's no log. You don't see any log, right? We only see exponents and variables and exponents. So we're dealing with exponential functions. For exponential functions, what we want to do is we need to try to write it as same base if possible. Sometimes not possible. But if it is, write it as 1/5 is the same as 1 to negative 1 power 3x. 125 is same thing as 5 to the 3rd power to the 1 minus x. Okay. So then we can rewrite it this as 5 to the negative 3x equals 5 3 minus 3x. Okay. So the reason why we want to write the same base, now that we have same base, 5 raised to this thing equals 5 raised to this thing. So that means that this exponent must be equal to each other. So we can rewrite as this equals this. So negative 3x equals 3 minus 3x. And we solve for this equation. Okay. So actually you'll see that we're going to add 3x both sides. Then we'll get 0 equals 3, which is not true, right? So this one happened to have no solution. So this has no solution. And that's okay. You know, some equations doesn't have solution. Okay. Okay. Let's look at this one. Now this one has log in it, right? This is not exponential, log. So for log, the idea is similar. If we have same base, right, we can just let inside equal to each other. But before we do that, we need to do something about this 3. What do you think? Okay, so think about it. You can pause the video if you need to. What do we need to do first before we solve this? What we need to do is we need to bring the 3 as an exponent. Okay. So now we have log base 4 x to the 3rd equals log base 4, 54. That means since we have same base log, the left side and right side must be equal to each other. The inside part, right? So this tells us that x third must equal to 54. So what is x? We just take the cube root. Cube root of 54. Or we can just write it as cube root of 54. Again, for the quizzes, right, like this answer is fine. Right? We're not expecting exact decimal number. And for homework too, that's most of the case. Again, the homework will tell you, make sure to read the instruction. It will say round to decimals or just write exact answer. Okay. So this is fine. This is the final answer. And this is a positive number. And we can plug positive number right here, right? So it is in the domain. And we always have to check that in log expression equations. Now let's look at this one. We have ln 3x equals ln 5x minus ln x plus 1. So here, we cannot just let, as looking at the equation, we cannot just set it up as ln equal ln something, right? So we have to do something. So what we can do is ln 3x, we can combine this. It's the same base with ln of 5x over x plus 1. Now we have ln, and inside. Right? So then we can now let inside equal to each other. So 3x equals 5x over x plus 1. So we're now solving this equation. So how do we solve it? Let's add x plus 1 both sides. Oh, sorry, not add, multiply x plus 1 both sides. Then I get 3x times x plus 1 equals 5x. 3x squared plus 3x equals 5x. Then I'm going to subtract 5x both sides. Then let's factor this. 3x minus 2 equals 0. So either this has to be 0 or this has to be 0, right? So answer will be x equals 0, x equals, 3 over 2. Now for log, you must remember to check the answers. Can I plug 0 to all these expressions right here? No, because if I plug 0 here, it gives me ln 0, and that's not defined. So this is not part of solution. Okay. And 3 over 2, can I plug in each expression right here? Yes, you give us always positive inside of ln. So this is a solution. So make sure, must check solution. Only on logs though, because exponential functions, domain is everything, right? So if you write 0 and 3 over 2, it'll be incorrect, right? Because the knowing that you have to check the domain is the one of the main part of the problem, right? It's not like you write both of these and you get half credit. No, because then you're not thinking what natural log or log is. So make sure, remember, you have to check the domain always. Now let's look at this. This is a log expression. So for these, in order to solve for x, we just need to rewrite it as exponential. So this says x to the third power gives us 64. Right. Now you have to think about what is it? What x to what power gives me 64? 4, right? So x equals 4. So that's it for this problem. Okay, so let's look at part E. Okay. Okay, so we have log base 6 x minus 1 equals log base 6 x minus 2. So here we have this minus 1 right here. So because of this, we cannot just let inside equal to each other. So we have to do something else. So for this kind of problem, what we want to do is we want to put log in all the log expression in one side and all the non-log expression in the other side. So what I'm going to do is I'm going to subtract this log base 6 x minus 2 both sides. So I have this. Then I'm going to add 1 to have like this. So the reason why I do this is because now since they're the same base 6, I can combine this into one log. So I'm going to combine it to log base 6, x minus 1 over x minus 2 equals 1. Okay. Now what do we do? Okay, so think about it. What should we do now? Now we rewrite it as exponential expression. This tells me that 6 to the 1 power will give me x over 1, x minus 1 over x minus 2. Right, so we're just solving this equation now. So let me write it here. We have 6 equals x minus 1 over x minus 2. So I'm going to multiply x minus 2 both sides. So I have 6x minus 12 equals x minus 1. Let's subtract x both sides. Then I get 5x. Add 12 both sides. Then I get 5x equals 11. Oops. So x is 11 over 5. Now we must check this solution. We have to see if this x equals 11 over 5. So you see, we have to see if 11 over 5 can be plugged in right here, and they'll give us positive number inside of the log. So this part is okay. This part here is okay because 11 over 5 is bigger than 1. So 11 over 5 minus 1 give us positive. So that part is good. How about right here? This orange part right here. It's also 11 over 5 is greater than 2. So it will still give us positive number right here. So this is the solution. If it gives us 0 or negative in any of the 1, even if it gives us only negative number 1 log expression, that is not solution. Okay. So let's look at, sorry, I kind of crossed the line right here. So oops. So let's look at this one. Okay. So what should we do? Same idea. Try to have log in one side and numbers in the other side. So I'm going to add ln. I'm going to add ln 2 minus x both sides. Now what do we do? So this is the case where it might be useful to rewrite natural log as log base e, the same thing. Now we can rewrite it as exponential. Okay. So this tells us that e to the 22nd power gives us 2 minus x. So how do we solve for x? I'm going to add x both sides. Then I'm going to subtract e to the 22nd power. And remember, e is just a number, and e raised to any power is also just a number. So this is the final answer. Yeah, we can simplify this more if you want to using a calculator. Again, that's not necessary for our quiz, and for most of the homework, this is fine. Okay, so make sure you pay attention to the instruction of the homework problems. Okay, it will tell you to, for some of the problem, it will tell you to round to first decimal or second decimal. Then you just type this last part of the answer. You can type it on Google and just type. You can round to first or second decimal place. Okay. Okay. So let's look at part G. E to the 2x plus 1 equals 7. So this is exponential, right? Exponential equation. So there's no log here. Okay, but we need to involve a log. So let me write it a little bigger. When we have e to the 2x plus 1 equals 7, you know, to solve for this, we have to take natural log both sides. Like this. We're going to apply natural log both sides. The reason is because now that allows us to bring this 2x plus 1 as a factor in front of right here. So let me rewrite it. So we're multiplying 2x plus 1. Very important. Make sure you put parentheses around 2x plus 1. Okay. Then ln 7. Remember, ln 7 is just a number. Okay, so we treat it like a number. So now ln e is 1. So we can just write this equation as 2x plus 1 equals ln 7. Now let me bring this equation right here and we solve for x. So if 2x plus 1 equals ln 7, remember ln 7 is a number. So we just subtract 1 both sides, ln of 7 minus 1. And divide by 2 both sides, ln 7 minus 1 over 2. And this is as simple as we can write it. And again, we can't find a decimal answer if we type this in a calculator or if you just search in Google. Okay. So again, if the homework asks you to round it, you must come to this up to this point, then type in calculator or just type this in Google, and it will give you a decimal number. Do not like calculate. Do not use a calculator like this stage. Only use calculator in the last step, just for decimal answers. Okay, because if you use a calculator early, that's estimating. You have to estimate what ln 7 is. ln 7 is an unending decimal number, right? We only want to estimate the last step. Okay. Okay. Now 5 times 4 to the 3x power equals 2. Okay. So similarly, if we have exponential expression, we want to isolate exponential term in one side. So I'm going to divide by 5 both sides first. Then now we're ready to take natural log both sides. ln 4, ln of this. So what that allows to do is bring this 3x as a factor. So I have 3x times ln 4 equals ln of 2 over 5. Remember, ln 4 is just a number. So we can divide ln 4 both sides. So what we have left is 3x equals ln of 2 over 5 over ln 4. Then we divide by 3 both sides. To isolate, I have 3 ln 4 over ln 2 over 5. Again, this is the Simple as we can express the answer in the exact way without estimating, without rounding. Again, if we were to round it, you round it at the final stage. Okay. So let's look at this. We have exponential expression. Now here base is different. So we cannot just let 2x minus 1 equals x plus 5 here. So in this case, we actually have to take just natural log both sides again. And why natural log? It's just because it's simple to write. But it doesn't actually have to be only natural log. It also could be any log. Okay. So I can just do that actually. The answer is same. So it doesn't have to be natural log. I can just take common log. Regardless, answer will be same. So let me just try log this time. Log 2x plus 5. So one of the property of logs, it allows to bring exponents to the front, or I mean front as in we can multiply as a factor. So it doesn't have to be front, you can also multiply it here because multiplication order doesn't matter, right? So we can write it as a factor. Now very important here, must write parentheses. So 2x minus 1 log 3 x plus 5 log 2. Now here, log 3 and log 2 is just a number. Okay, so we treat it like a number, which means we can distribute each of these numbers. So I can multiply right here, multiply here, multiply here, multiply here. Okay, so let's just do that. So then I have 2 times log 3x minus log 3 equals log 2 times x plus 5 log 2. Now if you look at here, we want to solve for x. So there's term order x we put in one side, and others, this right here, this one and this one, will be in the another side. Okay, so let me subtract log 2x both sides first. So I'm going to subtract this both sides. Then I have 2 log base 3x minus log 2x equals, I'm going to add this both sides, which gives me this plus log 3. So now what I do, I factor x out here. So let me rewrite it here. Then I have x factor 2 log 3 minus log, let me actually get more room. Let me rewrite it right here. So I'm going to factor x 2 log 3 minus log 2 equals, right side just stay as it is, log 3. So I want to solve for x. I need to solve for x, so I need to divide this by both sides. So x just equals 5 log 2 plus log 3 over 2 log 3 minus log 2. So this is the final answer. Okay. Again, let me remind you, if the homework asks you to put in decimal, just you can type this in a calculator or on Google, it'll give you a decimal answer and round to the first or second, or round to decimal place it asks you to do it. Okay. But again, no matter what, you have to be able to come to this right here without any calculator. Okay. So let's look at an last one in terms of solving equation. 4x power equals 11. So I'm going to take natural log both sides. Again, it doesn't have to be natural log. Okay. But here, natural log is commonly used. So I'll just take natural log both sides. Okay. The reason, again, is so that we can bring this x as a factor. Then we have 4 times ln 4. Oops, sorry. It's not 4. X times ln 4 equals ln 11. ln of 11. So what is x? X is just ln of 11 over ln of 4. That's the final answer. Again, ln 11, ln 4. It's just is a number divided by a number. Okay. Okay. So now let's look at more application problems. So here it says a sample of bacteria taken from a river has initial concentration of 2.2 million per milliliter, and its concentration triples each week. Okay. So find an exponential model that calculates concentration after X weeks. Okay. So how do we do this? So first, remember, let's try p to the x maybe. P to the x. Okay. So here, the important part is recognizing, right? The recognizing that we have exponential model because it triples each week, right? We're not adding same amount, or we're not subtracting same amount. We're actually tripling every time unit. So in this case, time unit is week, right? So 2.2 is the initial amount, right? So that means we have 2.2 as the initial amount. Okay. So then we use the E to represent the exponential. So that's again, E is a number, right? About 2.7. So we need to write E. Okay. So let me write that E. Okay. Now it triples every week, right? So how do we write tripling every week? So this is very similar to the first video, no, not first video, sorry, module 8. Right, it's all related. Oops, sorry. I don't know why I write E here. It's related to the module 8 video, right? So it's not actually E in this case because it tells us triple, right? So hopefully you know by now. If it triples, we're doing 3 here. Then each week is X, right? So this is the equation. So how do we estimate concentration after 1.2 weeks? We just plug 1.2. P of 1.2 equals 2.23 to 1.2. Okay. So here again, there's a very similar homework question to this. Here you have to just type this in a calculator, or you can just type in Google. Okay, and it will give you an answer, and it will ask you to round to nearest integer. So just round to nearest integer. Again, for quiz, that won't be the case. Okay, in the quiz, you will not need a calculator to answer any of these questions. Okay, so this gives us about 8.22. So we can say about 8 weeks. Okay, again, the calculator is just one way to express the answer. It does not really help us learn the concepts, right? It's the fact that you need to be able to come up with this equation and know that you have to plug 1.2 is what's important. Right? So don't obsess, don't focus too much about using calculator in the homework but not being able to, because again, in the quiz, you will not be asked to estimate or find exact number or find a decimal number in the quiz. Okay, it's more about the steps, and the concept behind these is what's important. Okay, so let's look at another exponential model. So the size of p of certain insect population at time obeys this function p to the x 300 e to the 0.03t. So I'm going to write a little this bigger, 300 e to the 0.03t. Okay. So this is exponential model. This is what we learned new in module 9, right? Part 1 video, using e as a number right here. Okay. So determine the first exact t equals 0 days. So you just plug 0, right? Also t here, sorry. Then 300 times e to the 0.030. This gives us 300 e to the 0 power. E to the 0 power is 1, so we have 300. Right? So 300 is the initial population. And we can also see that by 300 being right here, right? Number multiplied to the e exponential expression. Okay. Now we're going to go B first. The order is a little messed up. So there's A, B, then we're going to go C, D, then E and F. What growth rate is insects population? So in exponential, we can tell the growth rate by looking at this right here. This is 0.03, right? So let me write 0.03 first. 0.03. 0.03 means that's 3%. We can multiply 100 and that gives us 3%. So it's growing 3%. So how do we know it's growing? First, because this number is positive. If that number was negative, then it would be decreasing. Okay, remember the k? This is talking about the k factor from the variable k from video part 1. Okay. So sketch the function, and the homework it will ask you to, there's a multiple choice, like pick a, sketching a function, or graph the function, but it will ask you to choose the correct graph on your homework. So one important thing is, first initial is 300. So when it's 0, we have 300 here. So we start from here. And it is exponential growth. So it should have, it might look like a very smooth curve, very, it is smooth. There's always smooth curve. But it might look like a straight line. But if you look closely, it will be a curve. And it's increasing. So something like this is a sketch. Okay. It's increasing. Okay, now let's look at part D. What is the population after 10 days? Okay, so that means we just plug P of 10. 300 e to the 0.03 times 10. Again, for quiz, this will be good enough. But homework, they ask you to round to the nearest whole number. And you only round until the final answer. This is the final answer, so you can just type in Google, or just search it anywhere. And also you can also type in your calculator if you have a calculator. If you don't, you can usually your phones also can do this. Your phones, smartphones also can do this calculation if you have a smartphone. But I think Google will be the simplest. Okay, so this will give us about 404,958. Okay, but nearest the whole number, so it will be about 405. Okay. So population will be about 405 after 10 days. Okay. Now let's look at part E. When will the insect population reach 1200? So now it's asking when means we're solving for time. That means we let this equation equals 1200. At what t value will make this equation 1200? So now this is just solving exponential function. So divide 300 both sides, and we'll get e 0.03t equals 4. 1200 divided by 300 gives us 4. Right. So then we take natural log both sides. Natural log both sides. We rewrite it here. Then I can bring this 0.03t right here, right, to the front, or multiplying factor. So at 0.03t, ln e equals ln 4. So here ln e cancels, ln is 1, so we can just write it as 1, which is not writing anything. ln 4. So t is ln 4 over 0.03. Again, I know I'm already telling you like 5th or 6th time. On the quiz, this would be acceptable, right? The quiz, it's not about finding exact numbers, it's about understanding these procedures, understanding the exponential function and its relationship. But for homework, it will ask you to find round to nearest 10th as needed. Again, you do not type in calculator until you come this far. If you type calculator here, you get a wrong answer because you have to round more. So no matter what, you need to be able to solve this. And this is the last step where you can just type in your internet. And let me type it. And I get about 42,2908. And so it will be just 42.1. Okay. Now, let's look at last part. When will the insect population double? Okay. So we know that this expression tells us the population after time, right? So double population will be 600, right? Since the initial was 300, so 600. Okay. So if we divide by 300 both sides, equals 300. Oops, sorry. Divide by 300 both sides, we get 2. So essentially, double means we're solving this expression equals to 2. And this actually, even if initial population wasn't given, or it did not give us initial population, right? We can still solve for it. So let's say all they give us was just a to 0 e to the 0.03t. Then double time means just 2 times a to the 0 as a population. And we divide by a0 both sides. a0 just means initial population, whatever that is. And regardless, we're still solving for 2, right? So for double population, or also there's the idea of half-life. Same idea. We don't need to know actually initial population to solve for double. Okay, as long as we know this part right here, the growth rate or decay rate. So here, this is just solving another exponential equation. Take ln both sides. Then here I have 0.03t times ln of e equals ln of 2. This is 1. So t is just ln of 2 over 0.03. Okay. So let me type that in a calculator or search in Google. I get about 23.1 weeks. Because in this problem, we're in days, sorry, not weeks, days. Okay. So what do we do? Okay. So in the homework, there's a very similar problem in the homework you'll see. There's another problem in homework that will ask you the half-life. Okay. So half-life. So let me give you a quick idea how to do half-life. Very similar to this. Half-life. So for example, if equation is this, well, for half-life it has to be decreasing. So let's say I have point negative 0.12 t. That means it's decreasing at 1.2%. Okay. If this is the population equation, the half-life is we set that equation equals 1/2 of a sub 0, whatever a sub 0 is. Okay. So then, when we solve for it, a sub 0 will cancel out. So you just solve for this equation for half-life essentially. Okay. Okay. So let's look at expansion model in finance world. Okay. So it says account with an initial deposit of $6,500 earns 7.25% annual interest, compounded continuously. How much will the amount be worth after 20 years? Okay. So here, let me discuss the compound. Okay. So idea of compound. So let me just roll a note here, compound. Again, this is one thing that we can directly use in our real life, right? We either have a bank account, we eventually will own a bank account, right? Whatever stage of life you're at, right? So what does it mean by compound interest? So let's say, just look at a simple example. First month, let's say I had $1,000. And second month, I earn 10%. I know that's a lot, but you're lucky and we earn 10% every month, just for an example. So what is 10% of 1,000? Right, I gain 10%. I add 10%. Right? Then I have 1,100 second month, right? Now third month, I another 10%. Now when I earn 10%, I'm going from 1,100. I have a new balance, right? So I earn 10% of 1,100, which is 110, right? That's a 10%. So I add 110 to here, and that's new balance here. So now that's 1,210. Now if I add another 10%, right? I get 10% from here, then I add it to fourth month, right? This is the idea of compound. It compounds from previous balance, and you add, or sometimes you lose, right? So here the compound interest means that I make 7.25% of what I have here, but it compounds continuously. So it's keep compounding from new balance. And for compounds continuously, we use this E right here, exponential. So exponential can be used to model interest that compound continuously. If it's compound quarterly every year, then we use different formula, right? It will be 1 plus 1 over 4. If it's every month, it will be 1 plus 1 over 12. But if it's continuous, we use E. Okay? So this is where we talked about this, right? 1 over n. 1 plus 1 over n. Right? If it's quarterly, we use, instead of n, we use 4. If it will be every month, you compound every month, then we use 12 here. But if it's continuous, that means n goes to infinity. That's where we use E here. Okay, oops, let me erase this. So again, this is something that really used in real finance world. Okay, so let's set up the equation first. So let's say your account A, in terms of time t, initial amount is 6,500. And with E, now we have to write percent here. So 7.25% in decimal is we move 2 decimal places. So we have 0.0725. So I have e to the 0.0725 t. So this equation models how much will account be worth after 20 years. Okay. So this exponential idea is something that is not so intuitive. So what do you think? Before we solve this problem, why don't you guess? Think that just to explore the ideas, right? So think that you have 6,500. How much money do you think you'll have after 20 years if compounds continuously 7.25% annual interest? Right? Will be double? Will I earn $1,000, 2,000, double of 6,500? Right? So let's see. So just in order to do this, we should plug 20. Again, this we cannot do this with our calculator. Again, for quiz, this is fine, but this is just more for practice to see the application of exponential. So after 20 years, we'll have about 27,71074. So if this were to be real life, we have a balance of about $27,710 after 20 years, right? So it's more than triple. Just sitting the account for 20 years, it tripled the amount, right? So this is very powerful, right? To understand this, understanding this, right, help us have a more trust in this finance world, right? Like believing why I'm gonna have that much money. But of course, are we gonna be able to find the investment or bank account that give us 7.25, consistently? Like that's a separate idea, right? That's like, in terms of market value, we're only pure looking at just the mathematical side of it, how these calculations work, right? The finding those investment is, different, like a business side of the, right, of these issues or these ideas. Okay. So just sitting in the account, we may just more than triple. Okay. So again, this is very powerful. What if when you put 10,000, right? Would you also triple or be more? If you for 100,000, right? Again, these are not as intuitive, right? Because we're not adding same amount every time. We're adding 7.25% from the previous balance. Okay. So this is one area that exponential function is used a lot, is in finance. So how long would it take investment to reach $8,000? Okay, 8,000. So we just set this equation, 8,000 equals 6,500 e to the 0.0725 t. Divide by 6,500 both sides. We get 8,000 over 6,500 equals e t. You see the pattern by now. Take the natural log both sides. Then I get ln of 8,000 6,500 equals 0.0725 t, because ln e is 1. So for t, divide this number by both sides. T equals ln of 8,000 6,500 over 0.0725. Okay. So let's just put this, let me just search in Google to see what number this is. How long it would take me to earn 8,000, which means how long it would take me to earn 1,500. Okay. This is about 2.86 years. Okay. 2.68 years. Let me double check. Yeah. So in 2.86 years, the balance would be 8,000. Right? Again, in real life, right? And I'm sure some of you know already, having a fixed annual interest like 7.25% is not it's not possible, right? Like bank will not give you that amount for a savings account. And usually this interest amount changes, right? For the investment or stock market, right? But we're just focusing the calculation to see how the money grows, right? So essentially, if you can find, right, a stock market or investment or a retirement fund that have an annual interest of 7.25%, right? Just bring $6,500 in your account. In 2.86 years, you make $8,000. Well, not make, but you make $1,500 more, right, from what you started. Okay. So exponential functions help us calculate or predict this growth and also decay, right? In some cases, there's decay. Right? It helps us calculate these certain situations in life, such as population and investment or growth. Okay, using these models. Okay, so yeah, I went over a lot of examples here. So make sure you understand every example before you try the homework. And let me just make one quick comment. So in this problem right here, I know I use log. I use log here just to demonstrate that it doesn't have to be always natural log. But usually we do end up using natural log because first, I think because we need to write ln instead of 3 letters, so it is a little shorter. And ln is more just standard procedure because every simple scientific calculator has ln, right? And we usually just stick with ln when we take log both sides, right? So it's not wrong to do log, like right here I did. You can even do log base 6 or log base 7, as long as you do the same base left and right. But usually the convention is just use natural log when we need. Okay. So make sure to review these problems. If you have any question, email me. This is part 2 of the video.